lecture 4.2, the second part of lecture 4, which is a description of the implementation element of innovation. We've already gone through the essentials of what we mean by implementation, and the rest of this lecture should be pretty fast because we're just asking you to think about implementation in the same way that we have the other elements, basically thinking about the writing pen example and the graphical representation for implementation. So no surprise here, we want to finish thinking about the last element, implementation, with our writing pen. Quick example, and nothing different in any of this list here. We want to list all the aspects of implementation involved in a pen, and I think as we do so, the 4.1 in lecture 4.1 we took a lot of time to give you explanation of what implementation is, since most people don't think about it kind of on equal footing with market application and technology, and also wanted to give you the example of TSMC, which really I think gives you an example of how you don't need to have a new market or a new technology necessarily. I mean, those things are involved, but that a good innovation could involve a significant change in implementation, or, if you think about TSMC, it was in business model and structure of the industry. If you want to innovate in the pen world, then of course you have to think about this element as well, most likely. And we're going to do the same thing we did before, which is a very basic example, and we can just kind of speak to it right off the top of our head, which is why we're using this kind of writing pen example from a didactic lecture point of view. But as before, if you were doing this for a real idea, you would be performing research and calls to industry and speaking with experts and other people that have succeeded or failed at businesses and technologies in similar areas, etc. So nothing different here again. So let's go through the implementation for the pen. Same thing as before, what are the methods for production of each component? So starting off with, in market and technology, we started off with, what's a potential market application, what's a potential technology in the pen. And here with implementation, we start with, for all the components that you see here, in the pen, what are the basic methods? For example, how is this is it injection molded cap? I assume it is, because I already have other knowledge in this area, but same thing with the body here. And what was it that took these disposable fountain pens so long to get here? Was it really in the technology sector, or is it more that the underneath here, we'll see in the next thing, is it that nib, the tip of the fountain pen, the disposable fountain pen, is that what took a long time, and that there was no way to manufacture that in a low-cost way? We don't know, but these are things to find out, which is how are these individual components made? Of course, related to that is the structure of the industry, which is for each one of these pieces, there's a particular company. And the question becomes, what company is associated with each one? So suppose that this cap is made by one injection molded company. How many companies, are there, and how many of them actually work in this area? How many actually make the thing for the pilot, and so on. And same thing here. Are these the same company or a different company? Is it are they related? What's their relationship? Are they owned by the same people? So the sort of players behind all the pieces, not only what methods of production are being used, but then also the structure of the industry itself. Then we mentioned in the 4.1, that business model is related to everything we've just said, and we want to ask, what are the business models for the pen company? For example, is it that the companies are vertically integrated? And remember, that's where, let's suppose that we, draw this pyramid again, where somebody, sources the materials, in this case, does the assembly, and then actually sells is actually marketing the pen directly to consumers. Is there such a company? Does Pilot really do? You can see Pilot here, of course, is the company. Does Pilot really do this whole thing themselves? Are they truly vertically integrated like the pyramid? Of course, with such a low-cost product and the huge volume, what we learned from the TSMC example, it's likely that's not the case. But and of course that leads to another idea, which is, hey, can I introduce some new innovation and change the business model if I go to a different structure and actually do have some vertical integration? Because I suspect that the industry is very much, there's somebody doing the injection molding, and then someone else is doing assembly from all those parts. All these parts, this injection molded cap and this, they all go in there, and there's some assembly going on, and then that's probably done in a very low cost world. And then finally you have Pilot up here, which probably does the marketing and sales. Maybe it's usually, typically, as we said, when industries get quite large, maybe this is how it works. I actually don't know, but for the purposes of this lecture, I'm just giving you an idea of the kinds of things that you think about in the implementation world that we're trying to build up here. And related to what I was just talking about, what are they supplying, who's supplying what to whom, and then finally, is there key technologies that force in implementation some IP strategy. This is a very important thing. Or are these all commoditized? Could there be new IP generated for a new idea that would change the structure of these industries? Oops, sorry about that. And that is something, again, that you'd have to research in order to find out. And it kind of overlaps, and I'll come back to this in the next lecture. Notice how it's impossible to think about implementation completely without thinking about, for example, technology in this case, because even though the strategy in the industry is related to the structure of the industry and who does what, and so therefore the IP, which is literally, if you look at how patents work, the method of writing a patent is literally the translation of an idea into language that then the legal system figures out how to parse into rights. So it's kind of an interesting thing. It's patents and IP themselves are literally implementation, because they're at the intersection between technology and market application. So of course they're in the implementation section, but it's really difficult to think about implementation elements alone without thinking of the other ones. And that's going to be, of course, the subject of the next lecture, which is that actually not only can you not help but thinking about the other components, but it proves the other elements, but it proves that they all affect each other. And that gets to, ultimately our final innovation model, in which, all elements actually depend on each other. And we'll come back to that. But anyway, what's the intellectual property relationship between different parts of the supply chain is an important aspect of implementation. Cost. In market application, we talked about price and buyer surplus. So what is the price that a product can be sold at for that application, and then how much benefit does the user get above that price to themselves, the buyer surplus. The cost, as you may recall, is the if I put all those, let's suppose I do have different suppliers giving me the cap and the nib and the other parts and the ink, and I have to pay a price to them for each one of those, but then I assemble this whole thing. I better be able to sell it at the pen at a price that's high enough to pay all those suppliers, plus have dollars left over, and that would be, as I said, margin and profit. And operating profit is after you subtract some things from that. So obviously, implementation contains the cost, because everything I just said about, I've got some suppliers that are going to give me, n number of parts if it's disaggregated, like the TSMC case, and here I am, maybe the assembler, and then that goes to, some of those products go to Pilot, which is the company that's selling this pen, and you assume that they own, the consumer. In each case, this person is sourcing materials, probably fundamental materials. They make it into simple components, and they have something goes out, and so they have some cost. They're able to sell it to the person above them at a price, and this difference is margin, which is, profit, but then you got to subtract some other stuff to get operating profit. But basically, you got to have enough here, and that's how, there's interactivity through this chain to arrive at equilibrium, at least, temporarily in the marketplace, where all these things are balanced, because the same thing, happens here. They have to, this price becomes a cost for them, and then these people need to sell up into Pilot, and they in turn get another margin, and of course then Pilot itself figures out what consumer the price is willing to pay for, and in their case all these costs better add up. And that's why these things migrate, because if new assemblers show up in a lower cost part of the world, then this can slide over and we'll go to a new assembler because my margin can increase. So implementation, when I think of any innovation, how can I not think of this? Because all of this structure of the industry, and let's suppose that I have a new way to assemble it that costs less, so I want to be this new assembler here. Well, I have to understand what the costs and prices are above and below me in the supply chain, because my new way to do this better be such that more value is given to one of these players, and preferably it's always probably the one above you, and so then that allows me to capture more margin, or maybe I'm happy with just displacing them. That's unusual, by the way, because there needs to be some sort of investment that goes into here in order to make this effort to change. So if you're just going to get the same margin as they would, that would seem pointless. And so this is how, of course, things improve. So you have to think about costs of each component. Another big question, I was very disappointed one time when I went to a private meeting by one of the largest private companies in a particular sector of the economy. And because they're private, they do more research and development and think more broadly about what they want to do in the future. So they have these private meetings where they bring in people, and there's a discussion about different ways they could innovate in the future and things like that, which I was very excited about. I was very disappointed that this company is a worldwide company, and margins have become so thin in their main products, which is always the case, right? If you're a big company, you have lots and lots of these companies that operate and bring in cash and principal, but the margins get smaller and smaller with time, because everybody figures out how to do it, and there's more and more competition. And unfortunately, regulation becomes a key aspect of the way that some of these companies work. They can use, and this is not for the idealists in the audience, but they can use regulation when things become very mature to help them. So, for example, suppose their process is one example. Suppose their process is ecologically better than the other process. Maybe there's not such a fantastic margin difference, but I get an effective margin, because what I do is, let's suppose there's country X, and what I do is I ask these guys to use, if they use a particular process, they're going to get penalized through taxes or a fee or something, basically regulation. And so their costs go up. And then finally, that means I can enter because now my process is more aligned to that regulation. And of course, a lot of times it's because I told country X that that's the case. So this is the problem with a highly regulated economy. These innovation processes, which involved implementation, are distorted, and you end up with products that are not necessarily the best and lowest cost. They get labels that people apply to them, but the truth is that that's just because maybe these folks are in collusion with each other. So all these distortions can happen, and unfortunately, regulation is something that large, mature markets use and try to alter the innovation environment. So, I would argue, of course, if you do that in a way, it's not real innovation, which is the title of our book. On the other hand, let's suppose it goes on for 30 years, and companies do appear with better processes from the point of view of this regulation. Is that real innovation or not? It's been the situation has been kind of created by artificial means, but if it's 30 years, you kind of look at that as the real innovation environment. And so if you get by those regulations, maybe you classify yourself as innovative, even though in some universal concept you actually aren't that innovative, right? So this is where it gets complicated. But anyway, that is all part of implementation. So like in the other cases, when you think about implementation, you can look forward in the future because you're not just talking about the way things are done today or the way things are done today in other industries. Is there a new business model that's never been done before because times have never been this way before? And the internet is a good example of that. Many internet companies aren't really innovating that much in technology or market application. It's pretty obvious that people buy stuff in a particular area. It's pretty obvious that everybody knows how to make code to sell things on the internet. But what they're doing actually is changing implementation by moving things to the web, and say they're disrupting the old business model, which might be retail. Having a physical store, and of course you're seeing this today rapidly everywhere. So that's a incremental innovation, if you will. People make a big deal out of it because we're kind of uninnovative right now. That's the most innovative things we're seeing. People just taking similar stuff and everything. They're just changing the business model and getting incremental innovation, and that's why it moves, because there is a benefit to doing it, but it's not the same kind of fundamental innovation as the transistor, and we'll talk more about that later when we talk about incremental versus fundamental innovation. So you have to think to the future about how things can change based on how other things have changed in the market application and technology space. Again, see, you can't really, and you end up not thinking only about implementation. You need to pull in other elements, and we'll talk about that next. This is just an example. I give you an example here written out, but here's another example that maybe you decide, instead of, imagine if this industry was vertically integrated, maybe you decide to start to outsource and have someone else make it. No one else is doing that, and then you have to figure out the costs of doing that, and can you invest and make all that happen, and still the benefits of doing all this end up returning more to you and your investors. Same thing here is that can you change the way the playing field again is done with licensing technology, and even if you do that, how much revenue can you extract? And it's going to take you time to implement that with those partners. So these are just similar things to what we've already been saying about how to think about the future. So you think about old and new implementation, not just the way things are currently structured in the industry, even though that's one of the largest problems that I see is that people always assume the current structure of the industry will stay that way forever, and actually the case is it never stays the same way. It changes eventually for everything. So as before, we have the pen market universe, pen implementation universe, and we've got the things that we talked about, business models, structure of industry, which I just labeled as structure of industry. Of course, this breaks up into I could show you what this really means is there's multiple possibilities in here of how the industry could be structured, given the changes in things today, but also the changes in things tomorrow. And geographical factors, which we didn't talk about too much, but where those things are made, what country they're made in, given the regulation concept that I introduced, so obviously, the multiple, geographies in here matter. The companies, and all their strategies, what the other companies are doing, they matter. The production companies, the injection molders, everybody else. The IP strategy we talked about. Of course, businesses where you decide to go business to business instead of overall and instead of the consumer directly. And then, of course, there's costs, which we said are the key here. We talk about price and buyer surplus over in the market application, but costs have to be in the implementation part because that's where the business model is and the structure of industry and all that stuff. So as before, how many of the dots need to be considered? The more that you consider in implementation, just like in the other things, the more possibilities you have for being innovative. Of course, that means that risk is higher because it takes you time to figure this stuff out, and you may be doing things very different from someone else, and therefore less is known. And so considering more things and trying to really jump into different space is higher risk, but of course higher payoff if you succeed. And so therefore the size in our little graphical representation, the size that encompasses these, sorry about that, the size that encompasses these other factors that we're willing to open up and consider, that represents the uncertainty in our little model here. So let's just summarize lecture 4 then on implementation. We've used the pen analogy again, and we developed a universe of implementation and then showed you the graphical representation. And what we'd like you to do is, as you did with the other elements, think about the reading glass example and actually do it, because that's the way that you can start to think about these different aspects and also develop questions about what you don't understand. And we will,